Hello there, this is Ms. Nakayama, and today's lesson is 5.3, double angle and half angle formulas. This is the last section where we have new formulas, and we're going to continue with the same model that we've been using. So here are the formulas that we have for this lesson. First off, sine of 2 theta is 2 sine theta cosine theta. Then we have cosine of 2 theta, and if you notice, it's on here 3 times because there are 3 variations of it. It's helpful to know. Basically, if you make a substitution in for cosine squared, then you'll get this. If you make a substitution in for if you substitute in for cosine squared, you're going to get this one. If you substitute in for sine squared, you're going to get this one. Okay, and you'll see as we go through, I'm going to help you figure out which one you want to use with. And then we have tangent double angle. Tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. These first 3, y'all, are all coming from the ones we just did, which is the sine of theta plus theta, cosine of theta plus theta, or the tangent of theta plus theta. So if you want to know more about where they come from to help remember, I'll be happy to show you. Come see me. All right, so this first example, like I said, follows the model we've been doing. If the sine of theta is 4/5 and theta lies in quadrant 2, okay, find the exact value of the sine of 2 theta. Okay, so what is our model? What do we do every time? First and foremost, we apply the formula to what we're trying to find. We're trying to find the sine of 2 theta. So our formula says that the sine of 2 theta is equal to 2 times the sine of theta cosine theta. And then at our next step, we evaluate, and that means everywhere that I see a trig function, I'm going to put parentheses. So it's going to look like that. And now I need to go figure out, well, I know what the sine of theta is because they told me it was 4/5. But I got to go find the cosine of theta. They tell me it's in quadrant 2, so I'm going to draw it in quadrant 2. My sine is opposite over hypotenuse. So if I use my Pythagorean theorem, I can find out that this bottom side is 3. But because I'm in the second quadrant, I write -3 to help you remember that the cosine is then going to be -3/5. And you just multiply straight across, simplify it, and you get -24 over 25. All right, number 2, using the same double angle formulas. Okay, this time they give us the same thing. The sine of theta is 4/5. What is the cosine of 2 theta? So if you go back up, y'all, all right, we're looking for the cosine of 2 theta, and that is the one I told you that you have 3 different ones. And you can use any one that you want, but it is easiest to use the information they gave us. And they give us the sine. And the only one that has just the sine in it is this guy right here. So that's the one I'm going to use for the problem. Because if you make a mistake in finding the cosine, then you've messed up the whole problem. So first and foremost, apply the formula. And this formula, I want to use the one that just has a sine in it. So that's 1 minus 2 sine squared theta. And then I evaluate, plugging in, putting parentheses where I see my trig function. And the sine, of course, is 4/5. And then simplifying it with your calculator gives you -7 over 25. All right, now we got to do the tangent. Okay, same problem. Sine of theta is 4/5. Theta lies in quadrant 2, so we're dealing with the same thing. All right, and I talked about this earlier. When you have this kind of problem, there are 2 ways of doing it. So method 1 is applying the formula, and that formula is the tangent of 2 theta is equal to 2 tan theta over 1 minus tangent squared theta. And then I evaluate. And when I evaluate, everywhere I see a trig function, I'm going to put parentheses. And now I've got to go find the tangent of theta. So that's that same triangle that we just had in the previous problem. Sine is opposite over hypotenuse. And Pythagorean theorem tells me that's -3. So the tangent is opposite over adjacent, which means it's going to be -4 over 3. So I plug that in, and I walk through, y'all, simplifying it without a calculator, but y'all are just going to put it in your calculator. So we'll just go ahead and do that. -20 over 16 gives me 24 over 7. If you want to know more about how I did this, but I'm doing that same thing where I multiply by the least common denominator to simplify the complex fraction. But I would encourage you to take this, put it in your calculator, and make sure you get that. Now, what is the other method? The other method is, if I'm looking for the tangent of 2 theta, do I know the sine of 2 theta and the cosine of 2 theta? Which we found the sine in example 1, and we found the cosine in example 2. So then applying the formula is, well, this is not really a specific formula. You already know the quotient identity. Tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. So I'm going to take those two values and plug them in and then simplify. Because remember, if we have the same denominator, I can just get rid of those things. So 24 over 7 is what we have. All right. Another way to practice is to use it to verify an identity. So if you look at this one, we have 3 sine theta plus 3 cosine theta quantity squared equals 9 plus 9 sine 2 theta. So what do? It tells me to work on the left side, which is right here, and it says square that thing, because that's what that is. So basically I'm getting rid of those parentheses. Same thing I've been talking to you about over and over again, and that is that A plus B quantity squared equals A squared plus 2AB plus B squared. So here's my A, oh goodness, and here's my B. Hold on one second. So I'm going to square A, and when I do, that's going to give me, hope y'all know, square the 3 and square the sine. So that's going to give me 9 sine squared theta. Then I multiply them together. 3 times 3 is 9, sine times cosine times 2. 9 times 2 is 18. So that's going to be plus 18 sine theta cosine theta. And then I'm going to square the last term, which is going to be plus 9 cosine squared theta. So apply a Pythagorean identity and simplify the expression. So as I talked about, that Pythagorean identity is the only one on the front page of that sheet that has squares. So where do you see squares in this problem? Is with the first term and the last term. So I know that the sine squared and the cosine squared together equal 1, but they both have a 9 in front, so it's going to equal 9 times 1, which is just 9. And then I carry down the rest of the problem. Okay? So if you can't see that, basically what we've done is that's 9 sine squared theta plus cosine squared theta. And what's in the parentheses is 1. 1 times 9 is 9. So that's how we get in that 9 right there. Okay? The last one says, name the formula used to simplify the previous step. So how do I get this step to look like that? Well, I've got the sine of 2 theta, and if I break up 18 into 9 times 2, then it looks like this. And 2 sine theta cosine theta equals the sine of 2 theta, because that is the double angle identity that we just talked about. So that's an example of what that verifying an identity looks like with that. All right, our last set of formulas, half angles, okay, tend to be a little harder because of this plus or minus, but basically that plus or minus is based on the quadrant, and I'm going to explain that to you when we do the examples. Okay, it doesn't mean you have two answers. It just means it can be positive or negative depending on where the angle is. All right, notice the tangent of alpha over 2 has 3 different ones. Okay, 3 different ones. And I'm telling you right now, the one that is easiest to simplify and easiest to deal with is this guy right here. Because you'll never have to get rid of a radical like you did there. It'll be a little more complicated. And you wouldn't have to rationalize the denominator. It's easier to rationalize this denominator than that one. So this is the easiest one to use if you can use it. All right, so let's look at our examples. First off, we have use the cosine of 210. They're telling you cosine of 210 is negative square root of 3 over 2. To find the exact value of the cosine of 105. Okay, so you should realize that 105 if we're trying to find this, okay, and they give me the cosine of 210, if I take 105 times 2, I'm going to get 210. That means that 105 is half of 210, so I'm going to use a half angle. So cosine of 105 equals 210 divided by 2. All right, and so the first thing we always do is apply that formula. And my formula says that's equal to plus or minus. That's not what I wanted to do. Let's go back. Is equal to plus or minus the square root of 1 plus the cosine of the angle. And this is the angle because you want to use the one that you know. So it's the cosine of 210. Now, we have to decide whether we want the plus or the minus. So what quadrant is 105 in? And 105 is in quadrant 2. And quadrant 2, the signs are negative, positive. So that means that the cosine is going to be negative. So when we continue, our cosine, we're going to pick the negative angle. That's how you decide whether to use plus or minus. So it equals, where's my equals? Down a little further. After I apply the formula, then I'm going to evaluate. So everywhere I see a trig function, I'm putting parentheses. What is the cosine of 210? They told you in the problem. Negative square root of 3 over 10. Negative square root of 3 over 2. Okay, now we have to rationalize this, and this is something that you do have to be able to do, but if you can get this far, it's half the problem, y'all. So, this is that same complex fraction I've talked to y'all about, so I'm going to multiply the top and bottom by 2, but because it's under a radical, I have to put it under a radical. So I'm keeping it under a radical, okay? On the bottom, 2 times 2 is 4, and on the top, 2 times 1 is 2, and these 2's cancel. That one cancels out with that 2. So that gives me minus the square root of 3. And then the square root of 4 is, of course, 2. You can't leave, square root of 4 is 2. You can't leave it like this because that leaves a fraction under the radical. So we did that because that also gets rid of, gives me a perfect square on the bottom and allows me to not leave a radical in my denominator. Okay, so that was the cosine of 2 theta. This time, use the cosine of 2 theta to find the exact value of the sine. So last time we found the cosine of 105. This time we're going to find the sine of 105. So we're going to do the same thing. Sine of 105 is the sine of 210 over 2. That's the sine half angle formula. So I'm going to go apply that formula. And when I apply it, okay, plus or minus, 1 minus, it's always cosine underneath here. And it's always that top angle. That's not what I wanted to do. Try that again. I wanted that, okay? Because it is what you know. It's an angle that you know. Now I've got to decide, do I want the plus or the minus? Again, 105 is in the second quadrant where it's negative, positive, and I'm dealing with the sine, and the sine is the second coordinate. So that means that I'm going to want the positive this time. So my angle, I'm going to evaluate by putting parentheses wherever I see the trig function. Cosine of 210 is negative square root of 3 over 2. And I'm going to do the same thing to simplify it. And I probably did that slowly. 2 plus the square root of 3. And then again, when you take out that square root, then you end up with square root of 2 plus the square root of 3 all over 2. It's okay to have a radical under a radical. You just can't have a radical in the denominator. All right, last example. Use the half angle formula to find an exact value of the tangent of theta over 2. Okay, so you're looking at this, y'all. This is theta. This is not theta over 2. So the first thing I'm going to do is go apply the formula to that expression. Tangent of theta over 2. And the easiest one, remember, is the one that had the sine on the bottom. And that was 1 minus cosine over the sine of theta. Well, if I have this picture, then that means next I'm going to evaluate. And I can evaluate using that picture wherever I see a trig function. I put parentheses. What is the cosine of theta? Cosine is adjacent over hypotenuse. So that's 7 over 25. Sine is opposite over hypotenuse. So that's 24 over 25. Put that all in your calculator. I did it by hand. You don't need to worry about that. But when you put it in your calculator, make sure that you get 3/4 and know how to use your calculator. So the last of our formulas, make sure that you write those down, practice them, and come see me if you have any help. Thank you so much for watching, and y'all have a great day.